Can we fire it up on video?
I can't right now. I have the fuel tanks over here right now, but they're empty, and my office is a little flammable.
Hello, everybody, and welcome to the Altium On Track podcast. I'm very happy to be speaking with Ian Hillier, COO and co-founder of Hacksmith Industries. If you've ever seen any of their videos on YouTube, you know that they make some pretty crazy stuff, and that's some of the stuff that we're going to be talking about today, so it should be a very fun conversation. Ian, thank you so much for joining us on the On Track podcast.
Yeah, thanks for having me.
Yeah, absolutely. Um, I've watched some of your videos, and I've watched a number of videos from folks that do electronics online, and they have different projects that they do. Your stuff is really unique, and I noticed that a lot of it is like we're taking the movies and making it real. And I even saw that in some of your videos you have like a Marvel intro where it says make it real, which is actually kind of cool. Maybe if you could just maybe tell us a little bit about your background and then how you got involved in doing all of this.
Yeah, so my background is mechanical engineering. I met my business partner, who's the CEO and kind of the front man of the organization. We met in high school, grade 9 tech class, and we ever since then we've been working on projects, either extracurricular through the school or just kind of in our garage, working on building cool things. And that led us into the robotics club. And then after that, we went to college together, studied mechanical engineering, graduated, continued doing projects together. And we wanted a way to continue making the cool things that we want to make and be able to monetize that. And that's kind of where the channel came from, is we just wanted a way to make cool things, and YouTube was a way to enable that. And I can hop into the history a lot more if you if you're looking for that, but
Oh yeah,
that's
definitely.
the gist of it. Yeah, so um, James has been on YouTube for 16 years now.
So basically
So
since it started.
yeah, pretty well since it started. Just making videos for the fun of it, and seeing, yeah, just a hobby, making videos. And then as we started working on projects together, he would make videos about the projects, about that sort of thing, and post them online. I was only interested in the engineering. I just wanted to make cool things, and he would make blog posts or videos about things. And he grew the channel to about 60 or 70,000 subscribers. And at that point, he decided to quit his full-time job and focused on YouTube full-time. And at the time, everyone thought he was crazy. That why would you quit a full-time job to do YouTube? This was 2015. And so he quit his job, and I was working at a really cool tech company. We were making incredible technology, and then he quit his job. I was kind of moonlighting with him, and I got jealous and quit my job. And again, everyone thought I was crazy for quitting my job, which was a really cool company. It recently got acquired by Google, um, and so he quit his job. I quit my job. I had 6 months of runway before I ran out of money, and at the end of that 6 months, I was getting married, and I wanted to buy a house and have the normal lifestyle. But of
I'm
course,
sure your fiance was thrilled.
yeah. um, yeah, so 6 months runway, and we had no income. Uh, yeah, maybe a couple $100 a month, and of course our expenses were higher than that. So had 6 months to make some money, and we focused on. We figured let's get views, and revenue will follow. And so we focused on making some viral videos, and fortunately, we made a quite viral video, which was the electromagnets Captain America shield, where there was a couple of giant electromagnets on an arm bracer, so you could throw a metal shield and catch it with the electromagnets. And this was right around the time of the Captain America movie release. The video went viral, and we were able to make some money, and we were able to continue doing the YouTube channel full time. And since then, the channel's been exploding. So Yeah, 2016, we had 100,000 subscribers, and now we have 12.4 million subscribers. Back then it was just the two of us. Now we have a team of 24 people, full-time 24 people, which is incredible. I can't, at the time, I couldn't imagine the growth that we went through. So yeah, I was kind of expecting, oh, this is just a job that I can work on my passion projects, and if I can make enough money to get by, then I'm happy. And now we're at a team of 24 people, and that's engineers, videographers. We have a merchandise team. We have, yeah, all sorts of people on the team that just dedicated to making cool things. That's kind of the passion of, or what drives the company. We want to make the fun prototypes that most engineers wish they were doing while they're working at whatever corporate job they're at.
Yeah, it's almost like the wouldn't it be cool if you could make kind of stuff.
Yeah,
Not necessarily stuff that's just from the movies, right?
I mean, movies, video games. That's kind of our bread and butter. Is we take a pop culture idea, and that's usually Iron Man or lightsabers or Thor kind of technology. We take that concept that everyone is familiar with, and then we make a real working version of it, and then we find the videos tend to perform better when we do it that way. And usually it's pretty interesting technology that way as well. But we also do, I guess, passion projects that aren't linked to particular IPs as well.
Sure, sure. And I think what's great about, what you guys do, especially like applying it to something that you would see in a movie and that seems, I guess you could say, impossible or really fantastic or just totally infeasible, is it really illustrates kind of the engineering mindset involved in breaking down something like that and then linking it with, what's available now to try and actually create something that demonstrates some of those same features. I was really impressed by like the lightsaber and the laser pack that was I think James was looking through glasses and using that to like fire the laser on a piece of cardboard. Like that kind of
Mhm.
stuff is really cool. And maybe it's not practical or super practical or anything, but I think it's really great because it illustrates how you guys kind of think and approach these types of things. And my hope with what you guys are doing and what other YouTubers are doing is that it gets kids excited about
Oh,
engineering.
it definitely does. Yeah.
Yeah.
Then like hundreds or thousands of testimonials that we've received of people saying, "Hey, I didn't know engineering was that. I'm going into engineering because of you guys." And now there's people graduating engineering because we inspired them to go into engineering, and now they're graduating, which is incredible. Yeah, it's definitely one of our goals as an organization is to inspire the next generation of engineers and inspire people into STEM fields, show
Yeah.
how interesting and how cool engineering can be, and the kind of things you can do with it.
Yeah, absolutely. And I mean, I just read a statistic yesterday in an iConnect article. I think I said something to the effect of in 15 years, like 70 or 80% of the PCB workforce and the electronics design workforce will have retired. So there's just this
Hmm.
massive generational talent gap that needs to be filled. So that's one reason I'm such a big fan of channels like yours and then other YouTubers who are trying to just make electronics fun, because I think electronics can be kind of this inaccessible thing. Like it exists, you have a phone, that there's like chips in there and stuff, right? But if you're not an engineer, you don't do electronics professionally, you probably don't realize the complexity and how much fun it can really be.
And yeah, how accessible it is. That I was the same way. I'm a mechanical engineer, so some of the making PCBs and whatnot, I didn't for a long time. I didn't realize how accessible and how relatively easy it is, that you can design a board, order every component you need from DigiKey with one click, and then um, order the board, have it delivered to you in sometimes 3 days, and then assemble it, and it's there. Of how quick and easy, and the boards are incredibly cheap as well. of sometimes $1 a board or something like that with a short run.
Yeah, yeah, definitely. Now, you mentioned something interesting, that you and James are both mechanical engineers. Did I hear that correctly?
Yeah, so James and I are both mechanical engineers, and so for quite a while until we started hiring more mechatronics engineers and electrical engineers, a lot of our projects were definitely more on the mechanical side, or the electronics that we were using were um, either ready-made things or Arduino based. We weren't making our own PCBs. Now we make a lot of PCBs because we have the resources to do that. But you can there's a lot of off-the-shelf components that you can make a lot of things without needing to make a PCB. But it's definitely better with a PCB.
Yeah, yeah. I was wondering, for a couple of guys who are mechanical engineers, how easy that transition was. And you brought up, off-the-shelf modules like Arduino, and I'm sure some other
Hmm.
stuff that's out there. You know, it seems like that would, I think that's a really good way for people to kind of make that transition into, learning about electronics design, figuring out how to put things together. But, like you say, eventually you're now designing custom PCBs for the stuff that you build. How hard was that transition?
Um, I would say it was a pretty organic transition. Is that as the channel grew, as the team grew, the complexity of the projects also grew. So we've been doing one video a week for the past 6 years, and that started with a team of 2 people doing one video a week to now a team of 20 people doing one video a week. And so that's either a massive efficiency drop or the complexity. Yeah, so the complexity of the project and the quality of the video has massively improved over the past 6 years. And yeah, so we have more engineering resources to spend on each project. And now um, with that, so it was kind of an organic transition as we brought on team members that were able to make PCBs, and the complexity of the projects required PCBs. It kind of, yeah, it was pretty straightforward.
So, as you're marshaling a group of 24 people collectively to work on a single concept or video each week, I mean, what's the process for working with other designers, other engineers, whether they're, mechanical, electrical engineers? What does that look like? And how do you how do you get all of these heads in different areas to kind of collaborate on one thing that you're trying to build, and not just collaborate, but get to a result that's effective in such a short amount of time?
We silo a fair bit. So instead of focusing on one project and getting it done with everyone working on that single project, we have something like 8 projects in the works at all times. So an engineer will have their own project, and sometimes it's a let's say there's the owner of the project, and then they bring in support as they need it. So, for instance, I'm working on we're calling the Hulkbuster Fist. So I I own that
Nice.
project. I'm kind of the lead on that project, but I'm bringing in resources as I require. So I have a co-op helping me with some of the design and testing of certain things where I get him to assist with things. And I have a shop tech helping with doing some of the fabrication, and I have someone helping make certain things for the video aspect down the line. And it's similar with other projects as well. So usually there's a much smaller team working on the project, and there's many projects in parallel. So
Yeah,
there's,
that makes a lot of sense. Yeah,
yeah,
and I'm sure you have that many people working on one project, you could get an issue with too many cooks in the kitchen, as they say.
exactly, yeah. Or supply chain issues that sometimes you have to wait a week for a part to come in, and then is the whole company on hold while that happens?
Yeah, of
Yeah.
course, of course. Yeah, that makes total sense. Yeah, and then with having so many people around, like you actually have a pretty broad pool of talent to draw
Mhm.
from, because I noticed that you guys do your own machining, some of your own components, like with the Halo gun. You guys built your own coils. I thought I was pretty impressed by that, because I think a lot of folks don't go to that level, especially if they're designing professionally, simply because it's like, we've got deadlines, we've got budgets, we got to get it out the door. We're not doing something super custom with components unless we absolutely have to. And so I like that you guys have the freedom to kind of play around and experiment with what you're going to do when you're building something. And I was pretty impressed by the talent that you have access to.
Yeah, it's incredible where we come from and now where we are today. And that's doing things in house. It's kind of because we want to. Like I want to have all the machines and all the toys and have be able to walk out in the shop and make anything I want. That's like kind of a personal goal of mine. But it works better for the videos, and it works better for prototypes. So because we're yeah, everything we do is a prototype, and it's something new and something different. It's hard to set up certain. It's easier just to make a one-off sometimes than it is to um, order a custom whatever it is. Yeah.
Yeah, yeah, absolutely. And I mean, try doing some of this custom stuff with, a company externally.
Hmm.
They're going to charge you too much. They're going to take 8 weeks, and so it's understandable. You got to build some stuff in house. But one thing I think that is really great about that is, it does really show uh, right down to the nitty gritty of what needs to happen to build some of this stuff. Like, I think the coil, go back to the coil production for a moment. I think that's a really good illustration of how something would actually get built, and that kind of goes back to the education and inspiring, younger engineers, and really educating folks about, what has to go into manufacturing some of this stuff.
Hmm.
Yeah,
Which is
and
still fairly high level compared to some of the manufacturing that's out there. But
oh, sure.
yeah.
Yeah, because you're focused on getting something that, like, it just has to get to the function.
Hmm.
We're not selling a million units.
Yeah, which in my opinion is the fun part of engineering. Making the prototype is usually the fun part. And maybe there's some QA people out there that would disagree that QA is the best part of it. But personally, I think the prototype is the best part of engineering. And really, it's only maybe 5 or 10% of the work of most places. But um, yeah, it's definitely the most fun.
Well,
Making one
for
thing.
anyone that's Oh yeah, so I was gonna say, for anyone that's interested in actually watching the Halo gun video where they actually do manufacture their own coils, look in the show notes. We'll have a link to that video. We'll also have a link to the channel so that viewers can watch the other videos that you guys have up. Um, One thing I wanted to ask you was, what are some of the challenges on some of the more interesting projects? Because I'm sure there's stuff that goes on, when you're making all these videos, as you're doing all the engineering, that obviously doesn't get captured on camera. Because
Mhm.
you've got limited time on, to put up something up on camera, and nobody's going to sit around for an 8-hour video. So, of course, I'm sure there are other challenges that you kind of overcome, and maybe boil down to something more concise so that it's, camera friendly. So like with the Captain American shield, or like the lightsaber, what are some of those challenges?
Um, yeah, I mean, often we try to show some of the challenges in the videos, but of course, it's not always possible. I'd say that the challenging thing is sometimes a project doesn't work, and if you have a timeline of okay, we have this deadline to get this video out, and your parts don't come in time, and you have to, and you design something, and it just doesn't work the way that you expect it to. But you still have this deadline, and you still need to get the mechanical engineering done, and then the fabrication, and then the system integration, and then um, all these things that need to happen in sequential order, and then you need to make a video about it and get it out in time. And sometimes the thing that you thought would be really cool isn't as cool, or it doesn't work as well as you thought it would. So yeah, there's times where we do a lot of research and a lot of work on a project, and then it just never becomes a video, or yeah, we've had some projects either start and be thrown out, or kind of been in the pipeline for years now. There's a project that's currently on the shelf that's coming. We're bringing it back this summer, but we've been working on it for about 3 years now. That yeah, just kind of off and on, and maybe it'll happen this summer. We've dumped maybe, I don't know, $50,000 into this project between the components and the labor.
I'm curious as to what this is. Do you want to drop any hints?
um, it's an evolution of our flying like Iron Man project.
Okay.
So we started with this goal of we wanted to fly like Iron Man, and we started doing some of the R&D behind it, and then Richard Browning beat us to the punch, and now there's someone else that has jet engines on his arms and on his back, and he can fly around like Iron Man. So once that happens, we kind of shifted the project to now it's flying like Inspector Gadget. So the current plan is to have two very large electric motors above your head, counter rotating and spinning giant propellers. So you're kind of your own little helicopter. You kind of have this
Man, I
helicopter
loved
hat.
Inspector Gadget when I was younger.
Yeah, so it's doable, but it's terrifying, and we have a lot of the components to do it, but doing it in a safe way is difficult and terrifying.
I was just thinking the same thing. Safety has to be a major factor when filming,
Hmm.
whether it's having large rotors spinning overhead, or whether it is using two very powerful lasers to burn through cardboard while you stare at the lasers.
Yeah, and safety has definitely evolved over the past 6 years as well. When you're two guys in a garage, you can get away with a lot more than you can when you're I think it's a real company. Um, if you're endangering yourself, that's one thing. But if you're endangering an employee, that's very frowned upon. Yeah, so
Yeah,
our
definitely.
safety protocols have definitely evolved, and it's a little more difficult to do certain things than it used to be.
Yeah, and I mean, with what you guys are building, this is, I think, you you mentioned that you're having fun building a prototype.
Mhm.
You're building quantity one, and I think by taking the prototype mentality and just getting to the functionality that you want, um, that means you probably really aren't afraid to fail. I mean, as you said, you've got, one project that's been sitting on the shelf for, what is it, 3 years. It's probably been resurrected and failed multiple times over that time period. So, I mean, it, pushing those designs to the extreme, you have to kind of not be afraid to fail when you're building this stuff, and really just say, we just want it to work, and forget about IPC standards, forget about UL safety, right? I mean, it's all just about
A lot of
getting
that
something
stuff
that gives you
gets
what you want.
a lot of that stuff gets thrown out of the window. Like, yeah,
Yeah.
usually when we're for electronics or something, yeah, you run. Let's say the first generation of lightsabers that we made. The first one was a nitinol wire wrapped around a insulated metal core, and so we were running that at I think 300 volts DC, and just turning on until it gets red hot, and then using it. It only really needed to work for a minute at a time, and then it would break, and we'd have to fix it and then start filming again and use it for another minute or two. And when it failed spectacularly. If you can imagine a 300 volts DC going through a wire that suddenly bursts, there's a massive arc that happens. It's quite bright and loud and scary. So
Makes for a great video, though.
yeah. So when we're making some of those things, you know that when you're only running it for a minute at a time, you can you can get away with some allowances that you wouldn't do in a industrial setting.
Sure, sure. I think, what makes that different from, the professional setting or the industrial setting, or even if it's just the proof of concept is, you're eventually thinking, how am I going to take this and transform it into something that can possibly scale,
Hmm.
or that's going to be reliable over the long term. I mean, even satellites have quantity one, and they're not necessarily going to manufacture a million of those, but they care about the long term reliability. And I like that what you guys are doing and not being afraid to fail or really push the envelope on designs. That lets you push something to the very edge of what is really possible with modern electronics.
Yeah, I'd say one of the most extreme examples of that is our hoverboard, where that project was, I think, the most powerful project we've ever made. It was running at around 100 kilowatts, and it was a kind of the size of about a snowboard with 8 electric motors and as many batteries as we could shove into it, drawing 100 kilowatts. So the thing would run for maybe a minute before the battery pack was completely dead, and it was running at maybe 99%, where it was it was very, very close to exploding at all times. And it did
Yeah,
explode
talk
a
about a
couple of
safety
times.
issue.
Yeah,
You said it did explode a couple of
yeah,
times.
yeah. We went. It was because the project, the video needed to come out, and so the ideal situation is that we should have gotten better speed controllers, but the better speed controllers were on. It would have taken too long to get them. So the existing speed control, the speed controllers that we could get, um, they were not as good, but we could get them quickly and we could continue on with the project. So we just ordered a lot of those speed controllers and we made do. So it was just very close to exploding every time we used it.
So 100 kilowatts going into a hoverboard. What kind of batteries are you using? You just
Let's
stacking a bunch of lipo cells,
Yeah,
just
there
really?
was I forget how many, but Tattoo Gen Z's Tattoo is a sponsor, so they send us the batteries that we require. So it's just very high draw lipo batteries, and there were a lot of them, quite a lot of them. I think there was
Okay, and then
2 or 4 batteries per motor pack, and there was 8 packs or eight motors.
sure, sure. Okay, yeah. So that's
Mhm.
a lot of lithium polymer. Okay, cool. Yeah. So I think the other thing that I'm wondering is, what are some of your favorite projects? Because I mean, you guys have been doing this for a long
Mhm.
time. Starting with a Captain America shield to get you to, I guess, really take off. Since that time, you guys have sponsors. You guys are just kind of experimenting with what's in the movies. You guys are experimenting with stuff you're interested in. Like, what's your favorite thing that you've done, and maybe what are some of the things that you would love to do in the future?
Yeah, so my personal favorite projects are things that involve um, number one, high current electronics. So when we use that, we usually use the high current to make something glowing red hot, and then some sort of mechanical aspect and elegant design. So a couple of examples of that is, yeah, my personal favorite project is our red hot rebar crossbow, which is a exactly as it sounds. You put a piece of rebar into a crossbow. You press a button. It pumps 2,000 amps through the rebar until it glows red hot, and then you shoot it. And that project just works flawlessly every time we pull it off the shelf, which is incredible. We made it, I don't know, 3 or 4 years ago now, and we use it every so often. Just pull it off the shelf, charge the battery, and it shoots a red hot piece of rebar. Um,
That's incredible because that's so much discharge so quickly to get that thing to heat up because I mean it's going to start to cool in what
Seconds. Yeah.
seconds. Yeah, seconds. It'll cool off, just enough to probably not touch it, but not going to be red hot. But, you have to get a lot of current in there very quickly. And then you're shooting a piece of rebar, so I'm assuming it's going through an electromagnet.
Well, it's using the spring mechanism of the crossbar.
Oh, you're
Crossbar.
using a
Yeah.
spring. Okay. Gotcha. Okay. Well, then that's another challenge, right? Because you have, red hot rebar and you have to mount that against a spring. So how do you keep it from ruining the spring or anything like that? That's extremely interesting.
And then some other of my favorite projects are lightsabers. I kind of mentioned before. There was the first generation of
Yeah.
lightsaber. The second generation of lightsaber was a titanium tube with a insulated tungsten core. So the interesting thing about that was the electricity would travel through the titanium tube and then back down on the inside through the tungsten. And the titanium, first off, it's a pretty high temperature, high melting point, but a very high resistance, which is perfect for a heating element. So the titanium would glow red hot, and tungsten, which has an even higher melting point, so it's very rigid at high temperatures, but is very conductive. So it was kind of a perfect combination to have that electricity make the titanium red hot on the outside and then keep it rigid with the tungsten core. So I made a few of those lightsabers, and they performed well on the internet. Of course, lightsabers work well. And now one of our engineers.
Now I see why a mechanical engineer has an advantage in doing this kind of stuff. Because most of the stuff that you just brought up as far as creating this was mechanical points, right? You cared more about the melting temperature. You cared about the mechanical strength. The conductivity is important, but you want it to perform a specific function. You're taking all of this together.
Yeah, and now we employ mechatronics engineers that have a uh, bit of understanding of a bit of everything. Yeah. So one of our engineers then one upped me with this one, which is actually a oxy-propane torch. So yeah, so you hook it up to.
Can we fire it up on video?
I can't right now. I have the fuel tanks over here right now, but they're empty, and my office is a little flammable. Yeah.
Of course, I wouldn't want you to burn down your office.
Yeah, but this is a glass blowing torch used for glass blowing, heating up glass and melting it in certain ways. So we just bought this torch off the shelf, and then which is a lot of what we do is innovating. We call it. You buy existing products and then you modify them into what you need. So yeah, this is a glass blowing torch that uses oxygen and propane, and it creates a 3 foot long flame that looks exactly like a lightsaber. And the incredible thing is that it's retractable. So you can press a button and the flame extends, or you press a button and it retracts. And so this is an example where we used a PCB is in order to get, I guess, if I was doing the project as just a mechanical engineer, I would have made that, and I would have lit it with, I don't know, a lighter or something, and it just would have been on off. But we wanted to go a step beyond that. We wanted to have a retractable lightsaber where you press a button and it would extend, and press a button and it would retract. So how do you do that? So number one, fancy valves. You need a way to control the flow of the of the gases. And with these torches, you need to have a very precise flow of those combustible gases to get the flame profile that you want. If it's not mixed perfectly, then the flame looks terrible or it doesn't work at all. So we got some fancy flow control valves, and then we made a PCB to control it. And in addition to controlling it, then there's also the sound effects. So there's the lightsaber sound effect as it's extending and retracting, and an accelerometer in the handle, so when you swing it around, it makes the woo, woo, woo sound effect as well. So, yeah, could we have done that without a PCB? Probably not.
Absolutely. Well, whether it's for sound effects or for all of the stuff that we use in our daily lives, I think you're underscoring that electronics is very important, and that people who are interested should definitely get involved by going and watching your channel and learning as much as they can. Ian, thank you so much. This has been a very interesting discussion, and I like having guys like you on. Anyone who's a YouTuber and is doing some interesting stuff with electronics, I think you guys are doing something very important by helping to get new entrants into the industry and just interested in electronics in, you know, whatever way is going to work for them. So kudos, congratulations on all your success, and keep doing what you guys are doing. I'm going to keep watching the videos myself.
Awesome. Thanks a lot for having me.
Yeah, absolutely. And to all the viewers out there, you can see some of the best of videos and some of the stuff we've been talking about in the show notes. Go ahead and click through to those videos on YouTube and give them a watch. And definitely subscribe to our channel if you want to see more podcasts. And we hope everyone will go and also subscribe to the Hacksmith channel to see some more of their very cool videos. Ian, thank you again. And to all the viewers out there, don't stop learning, stay on track.